So the derivative of natural log is 1 over x. The derivative with respect to x of u, where u is a function of x, is 1 over u times u prime. That's the chain rule. You have to multiply by the derivative of the inside function. And the way that that's usually expressed is just u prime over u. So for example, if you take the derivative of log sine x, well, log sine x differentiates to the derivative of the inside function over the inside function, which gives you just cotangent. So the derivative of log of some function is the derivative of the inside function over the inside function, just u prime over u. If there's an absolute value in front of your function, surprisingly enough, there's no effect. Log of absolute value of u still differentiates to u prime over u. To see why that's true, keep in mind that the absolute value of u is really a piecewise function, where if u is positive, then the absolute value does nothing. The absolute value of a positive expression is just the exact same thing. But if u is negative, then the absolute value will change the sign. And when you change a sign algebraically, you just put a negative sign in front of it. Right? Like for example, absolute value of negative 3, that's negative, so it's negative 3. 3. It just changes the sign. And this is how you change the sign algebraically. So, if u is positive, then this kind of comes quickly. If u is positive, you can disregard the absolute value and it gives you the exact same thing. But if u is negative, well, the derivative, well, first off, let's just say this. So for u that is negative, log of absolute value of u equals log of negative u. Because since u is negative, putting a negative sign in front of it makes it positive. And then when you differentiate, the derivative of negative u is negative u prime, and over the inside function, negative u, and those two negatives just cancel out. So it doesn't matter if the inside value there is positive or negative. Either way, you get positive answer for the results. Now let's try just a couple examples. So we want to differentiate, let's find f prime for f of x equals log absolute value of secant of x. And then try f of x equals log of log x. And actually, before you do those two, do part C, or do part C last, what does it matter? But part C will be f of x equals log of 6x. So press pause now and try those 3 questions out, and when you're ready to see the solutions, you can press play again. Okay, here are the solutions. So, log secant of x. I know I said to do part C first, but apparently I'm ignoring my own directive and I'm doing part A first. But this differentiates to the derivative of the inside function, secant x tangent x, over the inside function, secant x, which means the answer is just tangent x. So log of absolute value secant x differentiates to tangent of x. By the way, once we learn how to do integration, this result means that the antiderivative of tangent is log secant x. It's kind of an easy way to prove that result. Just start with this and use the result going backwards. Note that the absolute value had no effect at all. Part B. Our function was log of log x. So, the derivative is the derivative of the inside function over the inside function. This is our inside function. right? That is the inside function. Now the derivative of the inside function is 1 over x. And then we put that over the inside function. So 1 over x log x is just the derivative, which simplifies to 1 over x log x. Not that bad, actually. It looks confusing at first. Let's kind of stress, what is my inside function? The derivative is the derivative of the inside function over itself. And then c, I wanted to show for a very specific reason, log of 6x differentiates to the derivative of the inside function over the inside function, and then those 6's cancel out. Why that's interesting is that this is the exact same answer as if our function was just log x. So log of 6x has the same derivative as log of x, which means the slopes are the exact same the entire time, which means that these two are the same graphs. They have the same shape. The difference is that one is just bumped up. And the reason is because log of 6x is log of 6 plus log of x, which means it is just log of x bumped up by some constant. And so if log x looks like this, which it does, of course, then log of 6x is just that same function bumped up by log of 6. It's just the same function, just bumped up a bit.